In this chapter, we're gonna tweak the solver to make it better. So let's go. So now, after this new layer, so this one, the inside mesh, I would like to go back on the solver. So let's see what happened. Maybe I would like to decrease this one to 0, 0, 1. Okay, and let's see the result. So it seems to be good, but if I delete just there, let's say, blast, and on the point at inside mesh equal 1, I want to keep it. I don't have any propagation on the inside mesh. So this is the outside and the inside, and as you can see, there is no propagation. So we are going to fix that, and by creating a new geometry to propagate the color on. So let's create a for each there, main primitive. I want, let's say, this one, okay, and let's just use one single piece. So I would like to connect the inside and the outside. So first, let's convert the mesh with on line, convert line, and split the inside mesh, not you, at inside mesh equal 1. Okay, point. I want to delete the primitive as well. So add and delete geometry. This is good. And let's see with null what we have there. Okay, so this is the outside point and this is the inside. I would like to keep, let's say, just 1/4 of those points. So I could use different way, but I like to use the attribute wrangle. So let's say if at pitinum modulo of 4 is different than 0, 0, then remove the points. 0 at pitinum. Okay. So before I had 570 points, and now it should be 1/4. Yes. So now we'd like to create some connection with the outside. So let's do it with an attribute wrangle, not you, with the second there. I want to look for the near point, equal near point, second input, and the position for the reference. I want the position, so let's have the new position, let's say, point, the second input, the position, and with the near pitinum. So from this position, I want to add a new point. So and new pt equal add point, and add on the first input with the new position. Okay, so now I should have twice more points, and this is the case. And I just want to connect them. So let's add prim, the first input. I want the polyline, my current point, so at pitinum, and the new point. So new pt. And that's it. I do have my connections. So now let's merge everything. Merge. This, not you. Okay. Okay. So now if I get back my color, this one, Control X, there, and I want to see the result of the growing solver, which is there. So I need to Control X, Control V, like this. So it doesn't work anymore because I don't have any name attribute there, 0. So I need to copy it. Let's do it. Attribute copy on this one, and I want the name. And let's see if it works. Yes, it seems to be good. Let's see with all the pieces. Okay. In this case, I don't need to compute the velocity. So let's see the vel, it's there. So I will use the other way to move the points, and so not with this one. I just need an attribute wrangle, like this, there and there. I need before to copy the matrix. Okay, mat by name. It doesn't work because here the name is over the points and here it's over the primitive. So let's attribute promote it from primitive to points, and I want the name. So this is good. Now I do have my matrix, and I just want to multiply the position at p times equal 4 at mat, and it should be good. Yes, this is what I want. So now I can transfer the color from this one to this one. So let's move it a bit there, and I want this one as well to move it. Okay, and those one as well. So let's see. So here there is something wrong. I think it's because of the color. I don't have it there. Yes. And let's see. Yes, it works. So that's nice. I want to try with the solver. And again, check the inside. As we can see, there is nothing, because I have to fuse it. So here, if I go there, I want to fuse it. And let's use a very small one. So let's go back and retry. Yes, so now it works. So this is what I want. But at the same time, I would like to have a delay when it's propagating from the outside to the inside. And I just need to add very simple, like this. So let's take out this one, use the first one. I want the polygon edge, and I don't want this one, I want the maximum segment. So let's see. So why? If I say before it was like this, so it just need one frame to propagate over the inside mesh. But I want to say I need, let's say, 4 frames. So let's see the result. Here. Okay. So the inside is this one, and the outside is the one. And if I go a bit further to the time, I can see this is the inside and the outside. So there is a delay, not a delay, a delay now, and this is what I want. So this is good. But now, because we have created another geometry for the growing solver, this part will not work anymore because we need the polygons. So I just need to transfer it from this one. So I want this part there. Two. And I just want to transfer the color. So I just need an attribute copy actually. Before it, like this. So what happened? Here we can see it doesn't work. So I'm going to create an attribute to make it match there. So let's create an attribute wrangle, all of them there, and this one there. And let's call it I at cust id 1 equal at pitinum. Okay, so now let's go back there and see with the cust id 1. And now it doesn't work, it's still not working. And I guess it is because of that. Yes. So we are going to explain that with an example. So let's copy paste it there and dive inside. Okay, so let's take a look here. I have a grid with a texture, some UVs. I've added just a noise over the color, okay, and an ID from the pitinum. So let's see the viewport. There, okay, I do have that. So this is basic, but I think it's nice to understand and even to review. So on the first example, I just have an attribute copy with the CD. So it is going to check the point number of the first input and the point number of the second one, and if it's matching, it's going to copy the attribute CD for the corresponding point number. So it works if I just have this one, and actually just to be sure, I want to delete those Okay, like this. I want to delete the city. It will be easier. So let's see a new scene view. Okay, this is better. And if I want to copy, okay, this is better. Because on the right input, I just have a color with a texture, a color map there. So I've chosen the butterfly, but you could choose whatever you want. And here the switch with a sort over the random. So in the first case, it works nicely, but if I switch to the random ptnum, it doesn't work anymore. So that's okay. On the second example, even if it is on the random point number, it's still working because it's going to look for the ID. So in order to make it work, you need the ID from both input. It means if I delete it there, it doesn't work anymore. And if I delete it here as well, it doesn't work anymore. So this is what we expected. You can do the same thing with the point number on the first input, so it's going to make it match with the point number, the original one. But if you change it to the random one, it's not going to work. And there is another function that we can use inside attribute Wrangler. I'm not going to use this one for now, but the first one. So as you can see, we are going to use the find attribute val, and this is doing the exact same process, I mean almost, than the match by attribute. Because this is going to copy the color, but if we are using the second one, and this is what we cannot do with, I mean we can do obviously, but with other nodes, and I am adding the previous color, so it was a noise, I can just get the maximum of my current color and the color from the second input. So this function is really helpful, and I think we will use it. And let's see another example. So just a box. I'm adding an ID with the ptnum, same thing. On this one, I'm just creating new points and removing the primitive. So as you can see, there is 8 points. But if we look at the ID now, it's -1. So this is what I wanted for the example. And if I merge everything and fuse it, I do have the same number of points and primitive than the original one, but not the same ID. If we take a look, it's -1 here, okay? So even if I sort it with a random and I make a color there from a bounding box, I want to copy the result and it will not work, okay? And this is because of the fuse. So if we take a look to the geometry spreadsheet, there is 2 ways to fix that. The first one is just to reverse the inputs, and now with the fuse it's working. And another way is, let's go back to the original one, is to, inside the fuse node, we have attribute to snap. Let's add one, add the ID, and I want the last match. And as you can see there, this is my correct ID. So even if I sort it after, I can make it match by ID and I will have the same result. So this is what we want and what we are going to use. Like this. So let's go back to our geometry, and I'm just going to use this one, attribute to snap, last match, the cost ID one. Okay. So let's see now if it works. It seems so. I need to go a bit further. Yes, it is. So before it was like this. Okay. And now up. Just ID1, last match. But I could just reverse this input. So it's the same thing. And now it's good. Okay, so let's take a look to the result we have there. And this one. Let's see with the moving primitive and the facet. Okay, we feel more density over the effect, so that's good. This is what we wanted. Another thing is that I'm not really happy with the speed of the growing solver, so I would like to go back to the example. So let's copy paste this one. Okay, and see the viewport. And this is the current speed. If I want to change the speed, I need to change the mesh as well. So for example, if I subdivide it like this, as you can see, now it's twice slower. And I can even do it more. Okay, but I don't want to use this way because it's really heavy, and I will use another way. So let's create an attribute variable there with a new attribute. So let's say if at frame modulo of 2 is different than 0, I at inactive, let's say, equal 1. So what does it mean? Oh, it's not this one. I want the modulo. Okay. So what does it mean? It means that if I look to the geometry spreadsheet, each frame, the inactive attribute is going to change from 1 to 0 and 0 to 1. Okay. So now if I go back to the scene view and I'm saying inside the solver, I want this happen when at inactive equal 1, something wrong there. Okay, let's see the result. So now it doesn't work because I have to copy the inactive attribute, so attribute copy to update the value. Oh, not you. To the first input, and I want the inactive. Okay, so let's see the result. And now I do have a steppy propagation, let's say. So if I, for example, increase this value, let's set chf time step. Okay, not you. And let's get the parameter. I want, for example, 10. Now, oh, this is not what I should have. So let's refresh it. No. So let's go back to 2. Let's see. And maybe check the geometry spreadsheet. Yes, this is why. So, for example, the first one is 1, the second as well, third one as well, until the 9 one. And when I reach the frame 10, I have 0. So I just need to change this one to 0. And let's go back to the viewport and see what we have. Okay, so now it is growing every 10 frames. So now I need to use another variable, let's say, with, let's say, float stepping. So I want the random of the beginning. I want to fit this result. So let's use fit01 from 0 to the chf time step. So let's copy paste it there like this. And I just want to run to integer this result. So I will explain it. What is it doing? So basically each point now have a value, a random value from 0 to 10. So I'm doing that to add more variation inside the solver. So we just need to add parentheses there and set plus stepping. So let's see the result. So this is what I wanted. I think 10 is a bit high, so let's say 5. And we are adding with this way a lot of variation, and we can control the speed, let's say, with this number. So if I want to make it real time, let's set 1. So let's go back. And now this is our original speed. But if I set 2, now it should be twice slower, even though it's not exactly the case, but we can reduce the speed with that. So this is what I want, and let's rename this. Let's set a color, red color, add inactive attribute. Okay, and I would like to copy paste just this one here. So let's do it there. Actually, I'm not going to copy this one. I will just do it there. So I don't need the V and the N anymore. I just need the inactive. And I need to make it there. Equal 0. So let's see the result. Was it 0? I don't remember. Let's see. Yes, it was. So this is good. Let's make it, okay, 8. And now it's slower. This is what we want. So let's make a flipbook just to check the effect. There. And now, as you can see, it's way slower. So it's not exactly what I want, but we will change that later. I just would like to check, because it seems that maybe there is some error. So this is good. And this is good as well. So let's see here. Okay. This should be alright. And yes, I need to copy the CD as well, but it's there. So it should be alright. Let's reset this one and maybe change the viewport. Actually, I think it's just like an optic illusion, so if I take this off and go back, this is weird. So let's check it here directly with the blast. Okay, point. So this is the outside. And this works nicely. So here, if I copy this, it works as well. And here, yes, it works. So this is good. And the other one, it works as well. So it was the good result. So now let's make it a bit more organized.